Good afternoon and welcome back to Dr. Logic Awkwardly Does More Predicate Logic Proofs. But don't worry, I'm not actually going to do proofs today. I'm going to teach you how to do them. Well, of course, what you've gotten in the previous dozen or so videos has been me teaching you how to do them, but I want to talk a bit more in this video about strategy. So you may remember way back like 60 some videos ago in video number 72, I talked about strategies for propositional proofs, an algorithm that you can use so that at least at almost every single point in a proof, if you're stuck, it'll give you a hint about what to do next. Now, I say almost every because if you've made an assumption for negation introduction or negation elimination, or for disjunction elimination, and you're trying to find either a contradiction or a formula, the algorithm isn't going to tell you how to, like, what contradiction or which formula. So, with that caveat, what we're going to do in this video is talk through that proof strategy, but add in bits for our new connectives. Basically, everything that we could do with the propositional level, we can still do now. So that part of the strategy won't change. But we now have statements of identity, universally quantified statements, and existentially quantified statements. What can we do with those? So we'll start off in the same place. First of all, do you have any assumptions? And pretty much in every proof that you have, you will have some assumptions to start with. Look at them, and are any of them conjunctions? Break them down. Are any of them conditional plus antecedent? Break it down. So do all of the propositional steps. If you have something that is a universal statement, so its main connective is the universal quantifier, then look through your other assumptions and ask yourself, do I have any constants? If you do, the very first thing that you should do is universal elimination on that universal formula for each one of the constants that you have in your premises. Now, the thing about universal formulas is that they're universal. This means that later on in the proof, if you introduce new constants, you may need to go back to those premises and ask yourself, do I need to apply universal elimination again? So unlike some of the other elimination rules, for instance, you eliminate a conjunction, you do it once, you don't need to do it again. But because you could eventually introduce new constants into your proof, you always need to be going back and checking that. There will sometimes be cases where you've got universal propositions in your premises, in your assumptions, but you don't have any constants. Now, maybe the algorithm will tell you to do something else, in which case you can do that. But if the algorithm doesn't say anything, well, then just pick a constant. Take your favorite letter, whichever one that is, and do universal elimination on that constant, and then see if that gets you someplace useful. Once you've done that, now it's the look at what you're trying to prove and design your strategy around that. So if it's a conjunction, disjunction, conditional, negation, any one of these things, then follow the propositional strategy. If it's a universal statement or an existential statement, there will be different things that you can do. If what you're trying to prove is an identity, remember that identity statements, just bare identities, are atomic formulas. So treat them like that. If you want to try to prove an identity, assume that that identity fails to hold, and then do negation, introduction, or elimination. Similarly with negations of identities, non-identities. So we'll focus on what to do with the quantifiers. So if you're trying to prove a universal statement or if you're trying to prove an existential statement. So let me go ahead and bring up my whiteboard so I can kind of write down these clauses of the strategy for you. There we go. So we are looking at if you are trying to prove something of the form for all x phi, well, then you can derive this through an application of the universal introduction rule. Now, think about what this means. What do you have to have in order to be able to apply the universal introduction rule? So in order to apply this, you need to find phi with some term being used in it that you will be able to do your universal introduction on. So in order to apply that rule for all introduction, you need to first prove something of the form phi with explicit term tau in it. And because we've got provisos on when you can do universal introduction, make sure that you're kind of building those provisos into your goal. So we don't just want to prove phi of tau for any tau. We need this to be the case where tau is an entirely new constant. And what we mean by this is that it doesn't occur in any premise or assumption that our final conclusion will depend on. If you pick some new constant that doesn't already occur in your proof, then try to get to phi of that constant, then you know that you will meet all of the provisos necessary for being able to apply the universal introduction rule. So the other case is you're trying to prove something of the form exists x phi. So if you are trying to prove something of the form exists x phi, well, then you can use the existential introduction rule to get it. Now, the existential introduction rule in this kind of context, this very kind of narrowly focused context, is going to look a lot like the universal introduction rule, except that you don't have this constraint on which constant you pick. So what you need to do is prove, again, phi of tau for any relevant tau. So we don't have the constraint that it's an entirely new constant. And then you can introduce the existential on phi. So in each of these cases, how do you get a formula with one of the quantifiers as the main connective? You use the quantifier introduction rule for the relevant quantifier. Now, one thing that our algorithm doesn't really say is it never tells you things like when to use the identity rules or when to use the quantifier interchange. Generally, so I can just kind of say like useful heuristics. These aren't kind of part of any official algorithm. So if you have a negation followed by a quantifier, so negation first, quantifier second, always do quantifier interchange. It'll make your life easier. Try to drive that negation through the formula until it is as close to the atomic formulas as you can possibly get it. It will make your life so much easier. So you can do this with quantifier interchange for moving it across quantifiers, but then you can also use it, De Morgan's laws and double negation and all of these things that we had at the propositional level. We still have them in predicate proofs. If you have a statement of identity, use substitution of identity basically all over the place. Start off using it kind of indiscriminately. The more that you practice, the more that you will be able to see, okay, I'm trying to get some contradiction or something. I have not LA here and I have LC here, but I know that A and C are the same thing, so I'll do a substitution on one of those, and then I get my contradiction. But before you reach that point, just every time that you have a statement of identity, substitute through all of the formulas so that you basically have everything. If you're saying tau 1 equals tau 2, then every formula that has tau 1, do the substitution and get that formula with tau 2, and vice versa, because that will help you see the scope of kind of the consequences of the premises that you have or the things that you've already proven in your proof. It's kind of like with the universal elimination, where you just kind of indiscriminately apply it to all of the constants that you already have in your proof. Sometimes it may end up not being useful, but other times it might be. So these are kind of, as I said, useful tips. If ever you're in doubt, do a universal elimination, do a substitution of identity. But the important part in terms of the algorithm is that if you're trying to prove one of these quantifiers, set yourself up so that you derive the formula with a substitution instance so that you can then apply the relevant introduction rule. Otherwise, the strategy for proving predicate logic proofs is basically the same as for propositional proofs. They seem a lot more complicated because we've got a lot more connectives, we've got a lot more rules. Some of these rules have a bunch of little provisos that you have to follow. But once you memorize the rules and you master all of them, the strategy of doing proofs isn't any different. So, go ye therefore, prove your predicate logic proofs, have some fun, and I'll see you again soon. Take care.